Hello everyone, I welcome you all in this C programming and data structures lecture. This is part 3 of linked list implementation of stacks. So without any further delay, let's get started. Here is the outline of this presentation. First we will see the function called pop. That means we will see the code of this pop function. After this we will see the code of isEmpty function, then peek function. And finally, we are in the state to see the complete code in our favorite IDE. Let's see the pop function code first. Pop function of stack is similar to the del first function of the singly linked list with small changes. In the del first function, we will make some changes and it will actually work like a pop function. So pop function is actually similar to the del first function of the singly linked list. If you haven't watched the lecture on how to delete the first node of the singly linked list, then I would advise that please watch that lecture before moving on to this lecture. Okay, this is how our del first function looks like, and I took this code from the lecture where I've explained the concept of how to delete the first node of the singly linked list. Now here is the complete procedure which helps us in popping an element or deleting the topmost element of the stack. Let's see the complete procedure now. First, we will create a temporary pointer for the purpose of deletion. Then, we will update the temporary pointer so that it can point to the first node of the linked list. It is important that our temporary pointer must point to the first node of the linked list. We will use this pointer for the purpose of deletion. That means we will use this pointer to delete the first node of the linked list or the topmost element of the stack. Then we will store the value of the first node somewhere. Before deletion, we must store the value of the first node somewhere. It is important because pop function will not only delete the node but will also return the topmost element to the caller, right? After this, we must update the top pointer so that it can point to the next node of the linked list. It is important that our top pointer must point to the next node of the linked list. After this, we are free to delete the first node, right? Delete the node pointed by the temporary pointer and finally return the value of the first node. This is the complete pop operation procedure, right? First, let's create a temporary pointer for the purpose of deletion. This is our pop function and you can see I haven't declared anything in this pop function. Return type of this function is int because this pop function will not only delete the element, that is the first element of the stack, but will also return the first element of the stack back to the caller, right? That is why the return type must be int. Here I have to declare a temporary pointer, temp, okay? This is just a suggested name. You can choose any name of your choice. Here, this is struct node star temp, which means that this temp pointer will point to some node, right? After this, we must update the temporary pointer so that it can point to the first node of the linked list, right? Let's update our temporary pointer. Let us suppose that this is the initial state of the linked list. Currently, top pointer is pointing to the first node of this list, which means this is the topmost element of the stack, right? Now we have to update our temporary pointer, that is temp, so that it can point to this node. For this purpose, we must put this line of code, temp equals to top, right? In this way, the temporary pointer will point to the first node of this linked list. After this, we must store the value of the first node somewhere, right? It is important to store this value somewhere before deleting this node, right? For this, we will use a variable called val. Okay, this is just a name and I have declared this val over here. This is the pictorial representation of val and I will assign temp data to val. What is temp data? Temp data is 50. This is what we want to store, right? We want to store this value in this val. That's why we need temp data, right? Temp data is 50 and it is assigned to val. Therefore, we can put 50 over here. After this, we will update the top pointer so that it can point to the next node of the linked list. For this, we will put this line of code, top equals to top link. This will update our top pointer and eventually this will point to the second node of the linked list. Now you can see that temp pointer is pointing to the first node and top pointer is pointing to the second node. This will be our new top after deleting this node, right? Now we are in the perfect position to delete this node, right? Delete the node pointed by the temporary pointer. how to delete the node? It is very simple. We will call free function for this purpose, and to this free function we will pass temp, right? It is important that we must pass the address of the node that we want to delete to the free function. This will delete this node, and after this, of course, we must update our temp pointer to null, right? Then finally we must return the value of the first node. It is important that finally we must return the value of the first node, that is this value. So return val. That's it. This is the complete pop function, right? And this is the final result so obtained after deleting the first node of the linked list. We are done with pop function code. Now let's move to the isEmpty function code. Okay. This is how isEmpty function looks like. It is very simple. We must have to check this if top is equal to null. If it is the case that top is equal to null, then return 1, which means that top is null. And this simply means that our stack is empty. Else return 0, which means stack is not empty. Okay. Let us suppose this is the initial state of the linked list and top pointer is pointing to this node, which means top is not null. And this simply means that our stack is not empty. Therefore, this function will return 0. Top pointer will hold null when there is no node in the linked list. This is the old pop function and this is our updated pop function. Here I have added this piece of code. If is empty, print stack underflow and exit with exit failure status. This is an abnormal termination, right? If stack is empty, then stack underflow. We must print this message on the screen, stack underflow, and exit from the program immediately. We are trying to pop the elements out of stack. That is why it is important to check this condition. If stack is empty, then we must print stack underflow, right? This is our old pop function where I haven't added this piece of code. Now this is the updated pop function. This is obviously better than this function, right? Now let's try to write the updated print function. We are aware about the print function, right? Here first we have to declare a temporary pointer which must point to the first node of the list. Then after this we need this while loop for the purpose of traversal. That is, after traversal we would be able to obtain all the elements of the linked list, right? That's why this while loop is added. We are aware about this print function already. We have seen this in our previous presentation, right? This is the old print function, and here we can add this piece of code, that is, if stack is empty, then print stack underflow and exit with exit failure status. This is the new print function, right? And there is no doubt about this, that this function is better than this function, because here we are also checking this. If stack is empty, then print stack underflow. Okay. Now we are done with isEmpty function code. Let's move on to the peek function code. What is the purpose of peek function? Peek function simply returns the topmost element of the stack. And here is how the peek function looks like. We'll first check this condition. If stack is empty, then stack underflow and exit with exit failure status. Otherwise, return top data. Let us suppose this is the state of the linked list. Currently, we are available with this linked list and top pointer is pointing to this node. What is top data? Top data is 35 and we know that this is the topmost element of the stack. Therefore, this value is returned by peek function, right? Top data is 35. Peek function will simply return this data, that is 35, back to the caller. Now it is the right time to see the complete code in our favorite IDE. Here is the complete code. We have struct node, we have isEmpty function, we have push function, right? Here we are checking if new node is equal to null, then print stack overflow. Here we are checking the overflow condition already, right? After this, we have this pop function, we have peek function, then we have this print function, right? And finally, in this main function, we have this complete thing, that is, we will ask the user to push, pop, print the top element or print all the elements of the stack or even quit from the program, right? Eventually we have to ask, please enter your choice. If choice is 1, then we will push the element inside the stack. If choice is 2, then we will pop an element out of the stack. If choice is 3, then the topmost element will get printed on the screen. If choice is 4, then all the elements of the stack will get printed on the screen. If choice is 5, then it means that user wants to quit and we'll simply call exit function with exit failure status. And finally, the default case, if the choice is something else, then we will print wrong choice on the screen. Let's execute this code and let's see whether this is working fine or not. Let's say I want to push an element onto stack. Let's say it is 67. Let's say one more element I want to push, let's say 90. Then one more element, let's say 89. Then one more element, let's say 45. Let's try to print all the elements of the stack. This is how our stack looks like: 45, 89, 90 and 67, right? These are all the elements of the stack. Now we will pop an element out of stack. Deleted element is 45. This is the topmost element of the stack. That's why it is deleted. And now let's print all the elements of the stack. You can see our code is working fine. This was the previous state: 45, 89, 90 and 67. This is the current state: 89, 90 and 67. It is clear that this element is deleted, right? Now we will print the top element of the stack. You can see the top element is 89. You can see this over here. This is the topmost element, right? Let's quit from the program. Our code is working fine, right? Okay friends, this is it for now. Thank you for watching this presentation.